Session, I will not be going into what optimization techniques are, but I want to discuss with you some common terms which are being used in optimization. I'm very sure many of you have gone through the optimization program, so it may seem to be a repetition for you, but it is necessary that we clarify all these things before you can understand the next sessions, which will be taken by individual people who may not talk about this. They will be using this terminology. Now let's see what is optimization first. Optimization है क्या? Optimization to maximize or to minimize certain objectives. Okay, one of my friends here in the studio says to maximize or to minimize some objective. With certain constraints. Right? Then he has some with certain constraints. So it may have constraints or it may not have constraints at all. Now I agree with him, but I want to add that what I want to say here is that optimization getting the best results in the given environment under the given circumstances. The best results may be that I want to cut the cost, I want to make a product at the minimum cost, or I want to make a product in the shortest time, which may not be at the minimum cost. You see, there is a conflict here. First I said I want to make the product at the minimum cost. Second is I said that I want to make it in the minimum time. Now when I want to make it in the minimum time, the cost may not be minimum. Cost may be higher because I want to reduce the time. So I have to decide. I have to decide what I want to do. Whether I want minimum cost or I want to make it in the minimum time. So I should be very clear what I want. That means when we are talking about optimization problem, we should be very clear what is the objective, what we want to do. Now optimization is basically it is a mathematical tool, mathematical modeling of the physical problem. We convert it into a mathematical model and try to solve it. Right? Getting into the mathematics of the optimization problem may need a lot of mathematical knowledge, which we engineers should have. But at the same time, for the beginners, we should be able to at least use the optimization techniques which are already available. We should be able to know what optimization problems need, what these techniques need. They just need that you convert your problem, your physical problem, into a mathematical model. That is all. After that, you apply the tool. Of course, you should know what type of problem you have and which tool is the best suited to you. There are many tools available, but all the tools may be able to solve many problems. But at the same time, we should know which tool, which optimization technique is best for our use for the given problem. Now let's say go through it one by one. Let's say on the left side I have a very simple problem which we are dealing every day. On the left side I have starting point, and on the right side I have my destination point. Now I want to reach that destination point. There are so many links available between the starting point and end point, target point and the starting point. Now what do I have to decide? Maybe there are some paths, let's say taking an example, there are some paths where there is a toll load in between. That path may be shorter, but there is a toll load where you have to pay. There are other paths where the toll amount may be lesser. There may be other path where if you take selectively, you can reach the destination without paying any toll tax. So depending upon what I want, is it that I want to reach the destination at the earliest, I don't worry about the toll tax. Second is, I want to reach the destination without paying any toll. The path may be longer. Third is that okay, I will compromise in between. I can limit that okay, I'll pay around 100 rupees toll, less than that, right? And I will take a route where the toll tax is less than 100 rupees. If I can formulate my problem like this, that the distance traveled or the toll tax paid, whatever what is my aim? Or maybe I know that if I take a particular route, the road is not very good. I want to avoid that also. So I should be able to convert my problem, physical problem. This is the physical problem I have stated you. That is my requirement. That may be the requirement of a non-engineer. We are engineer, we can think on it. But maybe I had to provide a solution to a person who is not knowing all this. He doesn't know engineering at all. So I have to give him a solution that okay, if you do not want to pay any toll tax, take this route. If you want to pay, let's say up to 100 rupees toll tax, take this route. If you want to pay more than that, if you are open to any toll tax, then this is the shortest route you want to go. So that means, as one of my friends said here, it is basically getting the best solution under the given circumstances. Under the given circumstances. Now let's say one by one we will take this. Now this is a Latin word optimum that says this is the ultimate deal, and optimus means the best. Now the definition which I have just spoken, that is probably given. Optimization means obtaining the best solution or output under the given circumstances. Very important. If you say maximum or minimum, it may be somewhere else, right? I want a very good quality pen, but I don't want to spend more than 20 rupees. Otherwise, if you see the quality of the pen, you may get a pen for 2000 rupees. The quality may be much better, but I have a constraint. I don't want to buy a pen which is more than 20 rupees cost. So under the given circumstances, what is the best available? There are many pens available which are 20 rupees, which are costing 20 rupees or less than 20 rupees. So I want to choose the best. Maybe I will choose a pen which is costing 18 rupees or 16 rupees, but it is best under the given circumstances, right? So optimization means obtaining the best solution or output under the given circumstances, which may be obtained by finding the maximum or minimum value of a given function. Of course, optimization deals with maximization or minimization only, but the added constraint is under the given circumstances, what are the resources available? What are the resources available? Basically, when we talk about optimization, it is basically optimization of resources only, isn't it? We want to produce a component. What should be the route it should follow? What machine it should go through? Traveling salesman problem we have been talking, and everybody studies. Operation research and optimization has been used alternatively. Both have been used for optimization, right? But mathematics people more deal with operation research. I will not go into from where operation research came. Okay, it is an optimization technique only. Optimization or optimization techniques, as these are commonly referred to, are very powerful tools to solve the engineering problems in all disciplines. Now I am a mechanical engineer, and the persons, my friends who are sitting in the studio, they are all mechanical persons, but I know that people at the connected centers are from all disciplines. This course is not restricted to mechanical people. We call it as interdisciplinary program. Now everybody is using. Everybody is using optimization problem. Now in my field, in mechanical engineering, we day in and day out we use optimization. Starting from traveling marketing people, from plant layout, from optimization of cutting parameters, optimization of IC engine performance, any problem, any discipline. Let's say you want to have a column design, you want to have a required strength, but at the same time you want to choose the material also, weight also you want to keep it minimum. So choose a combination of materials, right? So every discipline, even let's say in computers, when they are arranging the components in the processor, they are using the same type of optimization which we are using in plant layout, because there are so many components to be placed in the microprocessor. The chip like microprocessor laga computer mein. So how to place them so that the space is utilized efficiently. Same is the case in our plant layout in mechanical engineering. We want to also use the system efficiently. All disciplines are using. Civil engineering is using, electrical engineering is using, mechanical engineering, computer science, electronics engineering, chemical engineering, process design. Everybody is using optimization because there's a lot of stress on the resources now. There's a lot of competition also. So you may not be able to, let's say, increase the price of any item which you are selling in the market, but at the same time you can reduce the inputs. The cost to the company can be reduced. That how do you do it? By optimizing the resources. To use optimization techniques for obtaining the best results, what we should know? We should have a physical problem, which we should understand. What are the variables which will affect the output? I'll give an example after that. What are the variables which will affect the output? That means you want to decide a product mix, and your organization is making, let's say, 10 numbers of components. There is a car factory which is making 800cc, 1000cc, 2000cc, all cars they are making. Now each car will give them some profit, different profits. जो 800 वाली है, that will give different profit per unit. 1000 जो cc है, that will give different profit. उससे बड़े engine है, that will give different profit. Now what should be the product mix? That at least you make some numbers of each type of car, but at the same time your profit should be maximum, right? So you should be able to you should know what are the factors affecting the output. What do you want? What is the target? Target is to maximize the profit, right? So what are the factors? How the profit is calculated? One thing is that, okay, simplest solution is that, okay, I will make only those items which are giving the maximum profit to me. है ना, एक कार मुझे 50,000 प्रॉफिट देती है, दूसरी कार मुझे 10,000 देती है. I say, okay, I will not make 10,000 rupees car, but that also I don't want to do, because I want to keep my presence in that segment also. In 1000cc जो 1,000 रुपए 10,000 रुपए मुझे प्रॉफिट देती है, उसमें भी मैं अपना I want to keep my presence there. So I say, okay, no, minimum मुझे 20,000 cars छोटी वाली भी बनानी है. That is the constraint, that means I have 20,000 तो मुझे बनानी ही है. I cannot go below that 20,000 number in one particular type of car. So that means I should know how my output is affected. What are the factors which are affecting my output? What is the output itself? We should be able to know. Output is my profit, or output is my time, or this is my distance traveled, right? Output in my case is efficiency of the IC engine. Output in my case is increase or maximizing the tool life of a cutting tool. I have that in mind. What I have decided, I have made a criteria that I want to focus on it. I want to focus on the profit, not on the time. But at the same time, I may have some constraints. So the user, to use optimization techniques for obtaining the best results, the user should understand the problem. You should first understand the physical problem. What is the problem? Variables affecting the output. What are the variables? What are the parameters which will affect the output of the problem? Find a measure of system effectiveness. How do you measure the effectiveness? क्या है मेरा profit है effectiveness, मेरा time है effectiveness, मेरा tool life है effectiveness. Call the objective function. And what are the constraints under which you have to work? Right? Constraint जैसे मैंने बताया कि इतनी मेरी कैपेसिटी है, I don't want to work in 2 shifts. I want to work only 8 hours a day. अगर मैं 2 शिफ्ट चलाऊंगा कंपनी को तो मैं ऑब्वियसली ज्यादा कार प्रोड्यूस करूंगा, बट I don't want to use that resources for more than 8 hours. That is a constraint. Right? There are some people from civil engineering also sitting here. Let's say you make that mixed design, concrete mixed design. You are concerned with the strength of the concrete mixed design. Now what goes into it? That you can decide with the help of optimization. That okay, you have different combinations of the components which are going into concrete mix, and my criteria is only strength. क्या डालते हो? That I also have decided which are the components which contribute to the strength of the concrete mix, and how much is the contribution. That also is known to me. That this component, material 1 has this much weightage, material 2 has this much weightage, material 3 has this much weightage, and maybe material 1 will be linearly, जैसे जैसे बढ़ाते जाओ वैसे वैसे उसकी स्ट्रेंथ बढ़ती जाएगी मिक्स डिजाइन की. मटेरियल 2 की शायद क्वाड्रेटिक हो रिलेशनशिप, नॉन लीनियर हो रिलेशनशिप. That also I should know. That means I should be able to make a objective function in terms of the variables which affect my output. Thank you. In day-to-day working, decisions are made to maximize or minimize a set of objectives. Some examples, you can read this. Designing the engineering process that can satisfy maximum productivity and minimum cost requirements. Now, there are 2 objectives here to be met. What are the objectives here? Maximum productivity and minimum cost. Productivity, of course, we could have written increasing the productivity itself, because productivity itself, if you define, it says without using more resources, you increase the rate of production. That is productivity. Obtain the optimal smallest path that the salesman should follow while visiting different cities on a single tour. That is traveling salesman problem we solve in OR. If there are small number of things to be done, let's say a salesman has to visit 4 or 5 cities only, I can sit on the table and decide that these are the options I have with me, and I can manually do that. Okay, this is the shortest distance which he will travel. I can decide manually. But as the size of the problem goes on increasing, let's say number of cities he has to visit is, let's say 20, 25, and there are multiple ways, pathways connecting those cities. Maybe manually I can do it, but it may take me 2 days, 3 days. Here I take the help of computer. I take the help of computerized software programs which help me in deciding my outcome, in achieving my outcome. मेरी outcome क्या है कि मुझे shortest path होना चाहिए. So they will give you that this is the shortest path. This computer will give you the short path. The only thing is you have to give some inputs, and I should know what are the inputs, what are the distances between the cities. Are there any preset priorities? कि सिटी नंबर 3 पे तो सबसे पहले जाना ही जाना है. ये भी तो कंस्ट्रेंट हो गई ना, ये भी कंस्ट्रेंट हो गई. तो I in bigger problems which are not possible to be solved manually, computer has been coming to our help. Computer has come to our help, and we have computerized programs where we do only small thing. We formulate the problem, formulate the objective function, formulate the constraints, and give it to the computer. There were days when people used to give the problem to the computer, and next day they will come and they will find the solution, because computers were slow that time, and there are so many iterations. बार बार करने पड़ते थे. लेट्स से हमने तो दे दिया कि 1 से 100 तक जाना है, एक वेरिएबल मेरा 1 से 100 तक वेरी कर रहा है, और हर स्टेप में 0.1 ऐड हो रहा है, इंक्रीमेंट हो रहा है. सो 1 से 100 तक जाने में 0.1 के हिसाब से बहुत सारी इटरेशंस बन जाएंगी. तो कंप्यूटर्स वर स्लो, तो व्हाट पीपल वर डूइंग कि आज इनपुट दे दी कंप्यूटर को, एंड कल जाके 24 घंटे के बाद जाके आपको सोल्यूशन मिलेगी. नाउ दैट प्रॉब्लम इज नॉट देयर. नाउ द कंप्यूटर्स आर very fast computing techniques we have, and we get the instantaneous solutions, or maybe still there's a problem in we are facing. Still we have some issues where computer takes time, maybe 4 hours, 5 hours still, but that is basically graphic based problems we have. But in this numerical problems, computer doesn't take time. You are just click the button and it gives the solution. Designing of aircraft and aerospace structures for minimum weight coupled with required strength. You want to minimize the weight, but at the same time, I have a constraint that the strength should not be less than this. What I should do? What I should know in this case? I should know what are the factors, how strength is related to the dimensions of the material, how strength is related to the other properties of the material. Poisson ratio से क्या है, Young's modulus से क्या relationship है, stress कैसे produce होती है. Unless I know it, I cannot formulate a problem here. And what are the different properties of different materials. अगर मेरे इसमें cost भी कहीं लग जाएगी, तो और constraint एक आ जाएगी मेरे पास, इससे ज़्यादा cost भी नहीं होनी चाहिए. Controlling the waiting and idle times and queuing in production lines to reduce costs. Simple. Selection of machining parameters for enhancing the tool life I discussed with you. Normally what we do is, we have a tool life equation. Vt raised to power n is equal to C. It has been modified after that to take effect of feed and depth of cut also. So if you want to maximize the cutting parameters, you should be able to write your objective function in terms of cutting parameters. The tool life depends on what? Tool depends on V, feed rate, depth of cut, and okay, let's say rake angle. But at the same time, there may be some other constraints on it. What constraints? Let's say my feed rate should not be less than 0.1 mm per revolution, and it should not be more than 1 millimeter per revolution. My machine cannot take it. My depth of cut should not be less than more than 5 millimeters. My surface finish should not be go beyond 5 microns. But when I say this type of statement, that surface finish should not go beyond this, I should be able to convert it into in terms of cutting parameters itself. So when the problem is solved, the computer or the whatever algorithm you are using, whatever techniques you are using, it gives you a problem, take into consideration the constraints. कि भाई मेरी surface finish भी खराब ना हो जाए, है ना? Concrete mixed design है, उसमें मुझे strength भी चाहिए, but at the same time probably I don't want to add to the cost of the components which I am adding to that mixed design. I want to have a layout for the components in a microprocessor. At the same time, I want that heat dissipation should be faster. कि उसकी heat अंदर ही ना रह जाए सारी, या हीट डिसिपेशन का पाथ जो है शॉर्टेस्ट होना चाहिए. दैट इज द कंस्ट्रेंट. Okay. Optimal designing of earthquake structure for minimum weight. Weight should be minimum, but strength should be there. Designing of water source system for maximum desired output. Designing of pipeline network for process industries. Shortest length of pipeline should be there. Planning of maintenance and replacement of equipment to reduce operating cost. Anything you think. आप कोई भी चीज सोचो उसमें ऑप्टिमाइजेशन लगेगी. If you are concerned with this. ये सारी चीजें जो मैं बातें कर रहा हूं, ये कर रहा हूं कीपिंग इन व्यू दैट हमारे रिसोर्सेज जो है कंस्ट्रेंट हैं. इज ए कंस्ट्रेंट ऑन द रिसोर्सेज. हमारे पास ओपन नहीं है सब कुछ. अगर सब कुछ ओपन है तो जो मर्जी उठा कर लाते हो, फिर तो कोई चीज नहीं है, सोचने की कोई बात ही नहीं है. So we are working under the circumstances that resources are constrained. Resources are limited, and we have to use in such a way that we get the desired output. Let's say I want the maximum profit, or I want to produce maximum number of components from a given material. जो मैकेनिकल वाले हैं उसमें एक स्ट्रिप लेआउट करते हैं हम शीट मेटल में, कि आपने एक छोटा सा कंपोनेंट बड़ी स्ट्रिप से बनाना है ना. तो कैसे कटिंग होनी चाहिए स्ट्रिप से कि मटेरियल जो है वेस्टेज कम से कम हो, कैसे लेआउट होनी चाहिए. आई डोंट नो वेदर यू रिमेंबर और नॉट. देयर इज समथिंग कॉल्ड शीट स्ट्रिप लेआउट. वो भी कंप्यूटर से करते हैं अभी. वो भी लेआउट की प्रॉब्लम है. द आइडिया इज दैट वी शुड नॉट वेस्ट मटेरियल. वी शुड मेक यूज ऑफ मैक्सिमम मटेरियल. So optimization basically is minimization or maximization. Let's say there is a function here, fx. As x changes, the function decides like this. It behaves like this. ये पहले मैक्सिमम से शुरू होके नीचे आ रहा है, फिर ऊपर जाना शुरू हो गया. ऊपर वाला करो देखिए, नीचे वाला छोड़ दीजिए ना. अभी x पे कोई मेरे x वैल्यू, दिस इज x एंड fx है ना. वेरिएबल इज x एंड ऑब्जेक्टिव फंक्शन इज fx here फंक्शन. सो fx फंक्शन जैसे साइन वेव होती है ना, वैसा तकरीबन चल रहा. एक जगह पे मिनिमम हो गया ये. सो वहां पे हमने मिनिमम वैल्यू ले ली. दैट मीन्स आई वांटेड टू फाइंड द वैल्यू ऑफ x here. x is called design variable here, which can change, which can have change. Fx is the dependent actually. It is an objective function which depends on the value of x. So as x is increasing, fx is decreasing to some value, and it again increases. Many of you are writing. There is no need to write. We will give you the slides. Okay. So it is better that you concentrate on what I am saying and talk to me. So if you see that the function has reached a minimum value and it has again started increasing, right? It may happen that after going up for some time, it may start coming down again. And it may not come to this minimum. It may, the point may be that, okay, it starts coming down and again starts going up, right? So you will say that, okay, this is one minimum. I am talking about another minimum here. But that minimum now may be higher than this. It can be lower also. But let's presume that that minimum is higher than this minimum. Now there are two minima here. So that the other minima I am talking, that is called local minima. Let's say I say, okay, between these values of x, you find minimum value of fx. That will be local minimum depending upon constraints or the starting values. This minima, for any value of x, there is no other value which is less than this during the range of the function itself. This is called global minima. Local minima and global minima. Depends where you start, depends what you want. Sometimes, let's say you have given a constraint that my x choose change between this value and this value, x1 and x2, and during that range only that local minima is coming in that range. So that becomes the final answer. You are not, because you are not allowing x value to go to this minima which I am showing here. I am not allowing that. Similarly, maximization problem, or if you want to change maximization problem into minimization problems, this is what has been done. This is the maximization of minus fx also. If you see the upper curve, this is the minimization of fx, whereas the lower curve is maximization of minus fx. That happens. There are techniques, let's say linear programming, I am told, only solves maximization problems. And if you have a minimization problem, you convert it into maximization problem by adding a negative sign on both sides. Okay, there are many. This is operation research we have been studying. We have calculus methods, quadratic programming, linear programming, dynamic programming. This we are going to talk throughout the week, so I am not concentrating on this. Now let's come to mathematical programming. As I have been telling that we need a objective function, right? Optimization problem it consists of an objective function, that is what we want, what is the output we want actually. It may be one objective or two objective also. I can have a problem where I need minimum cost and maximum profit, or I can have a function, I can have an aim that I want to have maximum profit but minimize the time also. I can have two objective functions, but these are called multiple objective problems. That means no, one objective function नहीं, इसके दो हैं मेरे पास. मुझे cost भी नहीं चाहिए या मुझे profit भी ज़्यादा चाहिए और time भी नहीं चाहिए. Then you say okay, profit को मैंने 0.8 देना है weightage, time को 0.2 देना है, या दोनों को बराबर बराबर देना है weightage. So by combining these two objective functions, you make one objective function. That probably will be discussed during this week. Okay, my idea is to discuss with the basics of optimization so that you are comfortable throughout the week. So maximize or minimize z is equal to fx. Fx can be it is not a small function, it can be a sum of small polynomials, sum of small equations, right? It should be there. Then subject to some constraints. Normally you say fx is the objective function and gx are constraints. Constraints may be inequality constraints or they may be equality constraints. Okay. Many things will be clear to you already actually. What is equality constraint? How you convert an inequality constraints into equality constraints by adding slacks and all. That will be covered in linear programming. That should be covered. Now let's say Mr. Deepam is sitting at the backside. He has made the slides. I'm just reading. Okay. Of course, he has discussed with me many times. We are working on some material. Let's say the practical problems. What we thought that we will not say that we want to optimize this equation. No, we want to have a physical problem with us and then convert it into a mathematical form. Just see, a manufacturer has 3 machines P, Q, R installed in his factory. Machine P and Q are capable of being operated for at most 12 hours. That means 12 hours की उनपर constraint है. P and Q cannot be operated more than 12 hours per day. And R can be operated only for 5 hours per day. उसकी कोई इश्यू है, कैपेसिटी नहीं है, मतलब व्हाट इश्यू इज देयर दैट वी आर नॉट डिस्कसिंग हियर. Now the person produces two items A and B each requiring the use of all the three machines. तीनों मशीन चाहिए दोनों कंपोनेंट को बनाने के लिए. The number of hours required for producing one unit of A and B on three machines is 1 to 1. That means for producing one unit of A, 1 hour on machine P, 2 hours on machine Q, and 1 hour on machine R. Similarly, for producing one unit of B, 2 hours on machine A, 1 hour on machine B, and 1.25 hours on machine APQR. They are required. He makes a then what is he getting? How is his profit calculated? If he sells one unit of A, product A, he gets 500 rupees, and if he he sells product B, he gets 350 rupees per item. Now, if it is a simple question, I will say that okay, if there is no question of timing on machine constraints, I will say okay, I will make only item A, which produces 500 rupees, which gives me. But there is constraint, because on machine B, component A takes 2 hours, whereas component B takes only 1 hour. That means in the time you are producing one unit of A on machine 2, you can produce 2 units of B. अगर आप इसको स्टैंड अलोन देखो तो उसमें एक A यूनिट बना के आपको 500 रुपए मिले अगर B मशीन को देखें उसी टाइम में. बट अगर आपने B यूनिट बना दी उसको 700 रुपए मिल गए. So that means you have to balance. I think manually I may be able to do it, but computer does it more efficiently. I have to tell the computer that I want to do this, right? Now let's say how do we formulate the problem. Now you just remember it that there are two products A and B, 3 machines. दोनों मशीन जो पहली और दूसरी है उन पे 12-12 घंटे की कंस्ट्रेंट है, तीसरी मशीन पे 5 घंटे की कंस्ट्रेंट है, और कंपोनेंट A बनाने के लिए 1 to 1 है और कंपोनेंट B बनाने के लिए 1.25 hours लगते हैं on 3 machines. Let's say how to convert it into a mathematical problem. Let's say now the way we presume that we will produce X number of A and Y number of B, right? Now how much profit X gives you now? 500 into X. One item of X A gives you 500 rupees. So because we are producing X numbers of A, so we get a profit of 500X. Similarly, one number of B gives us 350 rupees. So Y number of B will give you 350 into Y rupees. So what is the total profit? Z is equal to 500X plus 300Y. That is what we want to maximize. So what is the meaning of this maximization? That we have to find the value of X and Y so that Z is maximum. Now this is not the complete problem. This is only objective function. Complete problem is that okay, maximize this, Z is equal to or Fx is equal to Fxy is equal to 500X plus 350Y, subject to what? Item A takes 1 hour on machine P and item B takes 2 hours on machine P. So if you want to produce X items of A and Y items of B, that is the total time required on machine A. That should be less than or equal to 12 hours. So this optimization constraint has been formulated. X plus 2Y is equal to less than 12. That means ज्यादा जो मशीन P पे है वो लोड 12 घंटे से ज्यादा नहीं हो सकता और 12 घंटे ऐसे बनेगा X plus 2Y. Similarly, 2X plus 2 should also be less than 12 hours. क्योंकि जो आइटम B है वो मशीन 1 पे जो मशीन P पे 2 घंटे लेती है और मशीन Q पे 1 घंटा लेती है. हाँ जी, 2x plus y, sorry, 2x plus y. Then similarly x plus 5 or 5 by 4y is equal to less than y. And of course, x and y cannot be negative. It can be 0. X or y can be 0, but it cannot be negative. So this is my optimization problem. If you have understood this, that means we have understood how to convert a physical problem into mathematical model. This is what we call it a mathematical model. मैथमेटिकल मॉडल का नाम सुनकर डरने की बजाय इसको देख लो आप. ये मत सोचना कि मैथमेटिकल मॉडल क्या होता है. दिस इज मैथमेटिकल मॉडल. Now mathematical modeling may not be possible for all the problems you have. सारे जो प्रोसेसेस है ना, सारे जो फिनोमेना है, they are not capable of being converted into mathematics form. कुछ ना कुछ हम कई बार assumption ले लेते हैं कि ठीक है अभी इसकी वैल्यू तो इतनी होगी, या हम कहते हैं कि ठीक है, सबसे ज्यादा क्या होती है, टर्मिनेट कर देते हैं हम कि ठीक है तीन डेसिमल पॉइंट के बाद हम छोड़ देंगे. जो वैल्यू आएगी 3 डेसिमल पॉइंट के बाद तीन की वैल्यू के बाद जो आएगी उसको हम छोड़ देंगे, उसको कंसीडर नहीं करेंगे. बट दैट इफेक्ट्स द रिजल्ट्स. दैट इज हाउ मेनी टाइम्स सिमुलेटेड रिजल्ट्स आर नॉट मैचिंग विद द एक्सपेरिमेंटल रिजल्ट्स, बिकॉज उसमें हमें मैथमेटिकली वी हैव नॉट टेकन केयर और वी हैव नॉट बीन एबल टू कंप्लीटली मैप द मैथमेटिकल दिस फिजिकल फिनोमेना इनटू मैथमेटिकल फिनोमेना. Now same thing which we have been talking. What is objective function? The criteria or desired effect with respect to which the design is optimized when expressed as a function of design variable is called objective function. Maximize or minimize, इसको fx कहते हैं, z कह देते हैं, x1 plus x2. इसमें कितने वेरिएबल हैं? 2 वेरिएबल हैं. ठीक है. Optimal solution is represented by the points lying in the feasible region providing minimum or maximum value for the objective function. जहां जो भी हमें चाहिए, maximize चेक करना है, minimize करना between the given constraints, है ना. जैसे मैंने पहले आपको एक प्रॉब्लम दिखाई थी जहां पे कर्व बना रहा है, ऊपर से नीचे को आ रहा है. Now maybe if we restrict our region of interest to some value of x, उसकी वैल्यू कुछ और हो सकती है. अगर हम कहीं और कोई और रेंज ले लेंगे 5x की, तो उसकी वैल्यू चेंज हो सकती है. इट मे आल्सो बी पॉसिबल दैट वॉट एवर वैल्यू ऑफ x यू टेक, मिनिमम वही रहेगा. तो भी ओपन प्रॉब्लम्स भी हैं, अनकंस्ट्रेंट प्रॉब्लम्स भी हैं. Constraints we know. What are the constraints now? By now, I think in last 1 hour we have come to know what is constraint. Constraints are the conditions that must be satisfied while solving an optimization problem. Constraint क्या है कि मेरी मशीन की स्पिंडल की आरपीएम 4000 से ऊपर नहीं जा सकती. That is a constraint. आपका जो मैथमेटिकल फार्मूला है v is equal to pi dn by f 60, वो शायद आपको कैलकुलेट दिखा दे करके के 6000 आरपीएम चलनी चाहिए. बट मेरी कंस्ट्रेंट क्या है कि मैं 4000 से ऊपर नहीं लेके जा सकता. या तो मेरी मशीन में कैपेबिलिटी नहीं है, या मुझे लगता है टूट जाएगी मशीन उसके बाद. सो मैंने वो कंस्ट्रेंट, जब भी मेरी कैलकुलेशन 4000 से ऊपर जाती है तो कंप्यूटर क्या करता है, उसको 4000 बना देता है कि नहीं इससे ऊपर नहीं जा सकता, बिकॉज द यूजर हैज गिवन अ कंस्ट्रेंट. ऐसी चीज बनाने का क्या फायदा जिसकी यूजेबिलिटी नहीं है, विच यू कैन नॉट यूज. I can give a value output of RPM to 4500 rupees, 4500 RPM, but मेरी कंस्ट्रेंट तो 4000 है, तो उसका कोई फायदा नहीं है. अगर मैंने उसको कुछ रिजल्ट आपको दे भी दिए तो यूजफुल नहीं है. Constraints may represent some physical values of a variable or some functional relationship among the 2 or more design variables and other design parameters representing certain physical phenomena and certain resource limitation. There are several types of constraints, primarily equality constraints, inequality constraints and integer constraints. आप देखिए ये भी constraint है. x1 plus 2x2 is equal to less than 4. ये कोई एक वेरिएबल पे कोई constraint नहीं लगी. एक्स या वाई पे नहीं लगी, बट उनकी सम पे लगी है, उनके ऊपर कोई रिलेशनशिप में लगी है कि x1 प्लस 2x2 शुड बी लेस देन और इक्वल टू 2. दैट मीन्स देयर इज सम रिलेशनशिप बिटवीन x1 एंड x2, वो भी मेंटेन करनी है. अगर मुझे एक टेबल बनाना है, एक टेबल टॉप बनानी है, उसके साथ उसकी 4 लेग भी बनानी है. मतलब ऐसा नहीं कि टेबल टॉप तो मैंने बहुत 100 बना दिया, लेग 50 ही बनाई, उसका कोई फायदा नहीं है. अगर 4 टेबल टॉप बन रहे हैं तो 4 लेग्स बननी चाहिए उसकी, एक 16 लेग्स बननी चाहिए. दैट रिलेशनशिप इज आल्सो देयर. दैट मीन्स मे बी x1 इज इक्वल टू 4x2. Design variables. What are the design variables? The variables which affect your output, which you can vary. जिस वेरिएबल, जिस आइटम को आप वेरी नहीं कर सकते, उस पर तो काम करने का कोई फायदा नहीं है. अगर मैं कहूं कि मुझे आरपीएम तो 4000 ही रखनी है, तो दैट डजंट इफेक्ट माय आउटपुट एट ऑल. जो उसका तो इफेक्ट कांस्टेंट है, वो मेरी इनपुट पे वेरी नहीं कर रहा. अगर मेरे पास उसको वेरी करने का कोई तरीका है एंड इट इफेक्ट्स द आउटपुट आल्सो, देन ओनली इट इज अ वेरिएबल. So you can write it in a form of, we normally write in, okay, we can say that okay, these are the variables x1, x2, x3 up to xn, or we can write it in the form of a matrix row, single row, that okay, capital X is equal to x1 to xn, or is xi, I varies from 1 to n. Now that is called a design vector actually. These are simpler things, very simple things. I am enjoying teaching this, but at the same time, unless you understand this, you don't understand optimization at all after this, because the next speakers will directly talk into design variable, design vector, nothing else. Now what are the variable bounds? Variable bounds are the values between which the variable can lie. Let's say I say x जो है, जो मेरा है वेरिएबल है x1, that should vary between 3 and 6. That means it can have a value of 3, 4, 5 or 6. अगर मैं उसको 1 वैल्यू देता हूं, फिजिबल ही नहीं है, वो फिजिबल नहीं है. That means अपर बाउंड है और लोअर बाउंड है, मैक्सिमम वैल्यू एंड मिनिमम वैल्यू है. ओपन वैल्यूज भी हो सकती हैं. मैं कहता हूं कि x शुड बी ग्रेटर देन 0, इट कैनॉट बी नेगेटिव. दैट इज आल्सो वेरिएबल बाउंड. उस पर लोअर बाउंड है, अपर बाउंड नहीं है उसके ऊपर. Now you know what is a design vector now. What is a feasible vector? Feasible vector is by putting the values of those variables, all your design constraints are satisfied. Objective function की बात नहीं कर रहे हैं. There are many techniques. बहुत सारी techniques optimization की ऐसी हैं जो आपको एक feasible design vector पहले कहते हैं कि feasible value से शुरू करो. आप बताओ क्या feasible value है. Some values which will satisfy all the constraints कि पहले वो दो, वहां से शुरू होगा फिर optimization technique. कि एक फिजिबल वैल्यू आपने, let's say एक फिजिबल रीजन है, उसके अंदर आपने एक फिजिबल वैल्यू दे दी, वहां से वो इधर उधर देखेगा चारों डायरेक्शन में कि किधर चलूं और कहां पे मुझे रिजल्ट मिलेगा, मैक्सिमाइजेशन और मिनिमाइजेशन. मैक्सिमाइजेशन मिनिमाइजेशन होती कैसे है वैसे ऑप्टिमाइजेशन में? they actually compare the results. The process only compares the results. कि पहले स्टेप में क्या रिजल्ट आया था, अगर मैक्सिमाइज करना मुझे तो दूसरे स्टेप में क्या आ रहा है, तीसरे में क्या आ रहा है, राइट? उसी डायरेक्शन में जाता है. लेट्स से एक पॉइंट से हमने शुरू किया, वो 4 डायरेक्शन में उसने देखा, इधर उधर, जिस डायरेक्शन में मैक्सिमम बेनिफिट उसको हो रहा उस डायरेक्शन में चल दिया, उसमें आगे दूसरा पॉइंट ले लेगा. है ना, उसी डायरेक्शन में जाएगा ना, फिजिबल डायरेक्शन कहते हैं हम इसको, कि फिजिबल डायरेक्शन क्या है, कि इस डायरेक्शन में चलने से बेनिफिट हो सकता है। अगर आपको लगा कि आगे जाके वो घटना शुरू हो गया तो दूसरी डायरेक्शन में आ जाओ, कोई बात नहीं, कंप्यूटर है, हमें फिजिकली तो करना नहीं, प्रोग्राम है, प्रोग्राम लिख दिया एक बार, वो अपने आप करता रहेगा। ओके, एक पॉइंट मेरे और माइंड में आ रहा है, व्हाट इज द टर्मिनेशन क्राइटेरिया। मैं कहता है इटरेटिव प्रोसेस है। हाँ, अभी मैंने आपको ये भी कहा कि पुरानी वैल्यू को देके अगली वैल्यू लेता है, बढ़ता गया बढ़ता गया बढ़ता गया, कब तक बढ़ेगा, कब तक नेक्स्ट पॉइंट लेता जाएगा सिस्टम। क्या डिफाइन करेगा यूजर, कैसे डिफाइन करेगा, या तो नंबर ऑफ इटरेशंस, कि जी मुझे 2 लाख इटरेशन के बाद बंद कर दो, जो भी होता है ठीक है, मुझे एक्सेप्टेबल है। बट बेस्ट मेथड इज कि जब आपका इंप्रूवमेंट नहीं हो रही फंक्शन की वैल्यू में, और इंप्रूवमेंट जो है बहुत कम हो रही है, आफ्टर ऑल कंप्यूटर भी चल रहा है, उसका भी टाइम है, उसको भी हम कॉस्ट देते हैं, तो उससे हमारा क्या हो रहा कि कोई इंप्रूवमेंट नहीं हो रही। मैं कहता हूं कि ओके, इफ द डिफरेंस बिटवीन द सब्सिक्वेंट रीडिंग इज लेस देन 0.01 0.02, तो टर्मिनेट without going into how many times it has iterated. It will terminate when the difference between the two subsequent values is less than that given value. वो टर्मिनेशन क्राइटेरिया है हमारा। अभी मैंने एक बात की थी आपसे ग्लोबल मिनिमा और लोकल मिनिमा की। सबसे बड़ी प्रॉब्लम आती है इन सॉफ्टवेयर्स में कि आप लोकल मिनिमा में फंस गए कहीं, वो आपका एक्चुअली ग्लोबल मिनिमा नहीं है, तो हाउ टू गेट आउट ऑफ इट, बाहर कैसे निकलेंगे इससे। Maybe we'll discuss if I come back to this class again this week. We'll discuss how to get out of this global, local. That we'll discuss. So we'll discuss. Okay, good. Thank you. So we'll discuss this. In fact, on the last day it will be discussed when this when we cut optimization through intelligent techniques or soft computing, what we call it. ये देखिए फिगर, a feasible maximization of minimum problem is said to be unbounded if the objective function can assume arbitrarily large positive values at feasible vectors, otherwise it is said to be bounded. अब लेफ्ट साइड में देखिए, ये जो सॉलिड लाइंस हैं, एक तो एक्स एंड वाई एक्सिस है, बाकी को सॉलिड लाइंस है कंस्ट्रेंट ड्रॉ की हुई हैं। अब जो मेरी सोल्यूशन आएगी, it should satisfy all the constraints. Let's say less than constraints है, okay, first constraint is also less than 0 or less than some value, second is also, third is also. तो ये जो डॉटेड लाइंस वाला रीजन है, इसमें तीनों कंस्ट्रेंट सेटिस्फाई हो रही हैं, 1 2 3 all the constraints are satisfied. In fact 5 साइड कंस्ट्रेंट्स भी, कंस्ट्रेंट्स दो तरह की हम कहते हैं, एक कहते हैं हम बिहेवियरल कंस्ट्रेंट्स, जो उसके बिहेवियर से आती हैं। साइड कंस्ट्रेंट्स मींस के इट शुड बी लेस देन, x should be less than greater than 0, y should be greater than 0. These are side constraints. Or x should be more than 3, y should be more than 5. These are the side constraints. So अब देखिए इसमें बाउंडेड रीजन जो है, यही फिजिबल रीजन है। जब हमें कंप्यूटर कहता है कि आप हमें कोई फिजिबल स्टार्टिंग वेक्टर दो, तो इसमें कोई भी वैल्यू दे दो, फिजिकल स्टार्टिंग वेक्टर है, यहां से चारों तरफ देखना शुरू करेगा कंप्यूटर। इसमें दूसरी साइड में, राइट साइड वाली फिगर में क्या है, अनबाउंडेड है, ऊपर वाली लिमिट कोई नहीं है, ऊपर कहीं भी वैल्यू हो सकती है मतलब, बट नीचे इससे नहीं जा सकता। जो एक्स वाई जब की वैल्यू है, ये इन लाइनों से नीचे नहीं जा सकता। इन फिजिबल रीजन की बात कर रहे हैं कि जो नीचे वाली, सबसे नीचे वाला एरो देखो, ये कहता है कि इससे नीचे होनी चाहिए वैल्यू, ऊपर वाले कह रहे हैं कि ऊपर होनी चाहिए राइट साइड को, तो इनका कंफ्लिक्ट है। एट नो टाइम ऑल द 3 कंस्ट्रेंट्स विल बी सेटिस्फाइड, तो इनफिजिबल हो गया सारा। है ना, ये तीनों तीनों कंस्ट्रेंट सेटिस्फाई नहीं हो सकती, तो इनफिजिबल सोल्यूशन, इसका सोल्यूशन है ही नहीं। ये फिजिबल रीजन की बात कर रहे हैं, ऑल द कंस्ट्रेंट्स आर इन दिस डैश्ड रीजन। Global maximum I have explained to you, global minimum also I have explained, global optimal point, global maximum और minimum पे जो भी point होगा उसको global optimal point कहेंगे। Okay. The polynomials where all the constants are of this you have an equation where all the constants are positive, polynomials. Polynomials can have a mix. Like here x1 plus 4x2 plus 5x3, they are all positive numbers. Now let's say, how do you classify optimization problem? These are the basics I have discussed. Still this is basics only what I am discussing. Linear programming, LPP sometimes we call it, linear programming problems. Linear programming problems are those where the objective function is linear as well as constraints are also linear. इसमें किसी की भी पावर जो है x1, x2, x3 की एक से ज्यादा नहीं है, इनको linear problem. इसके लिए simplex method use करते हैं, which will be discussed probably in the afternoon itself. How to form the problem, formulate the problem, and how to discuss the problem. Non-linear, where the exponent is not one for either the objective function or any of the constraints. मतलब आपके पास 10 constraints हैं, अगर एक का भी non-linear 1 से ज्यादा हो गया तो वही हमारी non-linear होगी, ठीक है। If the objective function or at least one of the constraints is not linear, it is called a non-linear programming problem. Geometric programming, if the objective function is expressed as polynomial in an optimization problem, it is called a geometric programming. Quadratic programming, अगर quadratic function है, quadratic तो आपको हमें पता है क्या होता है सब। Single objective, multiple objective I have explained to you. Both. इनको जाइए जरा, सो रहे हैं। Please don't sleep. मुझे भी नींद आएगी, फिर क्या करूँगा? Unconstrained optimization, जिसमें कोई constraint नहीं है। जैसे मैंने सबसे पहले प्रॉब्लम आपको दिखाई थी, एक कर्व दिखाया था, उसमें कोई constraint नहीं था, एक उसमें global minimum ही आ रहा है, but it will not be possible always. So optimization problem with no constraints is called unconstrained optimization. That means it says optimize fx is equal to x square plus 54 by x. No bounds. It can be 0, it cannot be minus, it can be plus. X can have any value. Constraint, where you have a objective function and you have constraints. Optimal control, non-optimal control will not do. Static optimization, dynamic optimization. Static optimization is, that means, okay, you solve a problem, standalone problem, and you give the, let's say you want to design a column. कॉलम डिजाइन हमने एक बार कर दिया, तो स्टैटिक पैरामीटर हमारे पास थे, उससे हमने सॉल्यूशन दे दिया, एंड उसके बाद कॉलम बनता रहेगा. डायनामिक इज रियल टाइम, एक्चुअली you are getting real time data and you have to take a decision. The problem is also known as trajectory optimization problem, which is used to calculate values for a domain of design variables. These variables are continuous functions of other parameters, right? You are getting some time input which are based on the, let's say, which are changing with time or which are changing with the values of some other inputs. So if you want to optimize some function based on that, that is a dynamic optimization. Stochastic, it is an optimization problem in which a few or all the design variables pre-assigned parameters lie in either category of stochastic, whether probabilistic or non-deterministic. Similarly, deterministic programming, it is an optimization problem which consists of all deterministic design variables. These things we will discuss during the week. Okay. Integer programming, where only you can have integers, right? Where you can have all real values, that is real valued programming. Nothing. It is only the title itself shows what is inside this. Separable program, where you can separate. An optimized problem consists of separable objective functions and constraints, and it is known as separable programming. That means you can separate the items. Where you cannot separate, it is a, let's say, multiplication of all the parameters within the objective function, then it is a non-separable. Now this is general guidelines. It is almost impossible to apply a single formulation procedure for all the engineering design problems. So you have many methods of optimization, and you choose which method is best suited. I am not saying that a linear programming problem cannot be used, cannot be solved by using a non-linear method. It can be, but why to use a resource which is not best suited for that? We are talking of optimization, and the technique which we want to use is not optimized technique. This is not used. This is not required to be used for this. It should be just good for that solution. So choose a technique which is best suited for that. उससे बढ़िया टेक्निक करने का क्या है ना? हम कहते हैं रिसोर्सेज की कॉस्ट हम बढ़ा रहे हैं. हमें नहीं लगता कि रिसोर्स की कॉस्ट बढ़ा रहे हैं कि तो इक्वेशन तो मेरे पास है ही है पहले. But if you see in the real value, we are actually using the resources which are not actually required for that. Linear program तो सिंप्लेक्स से सॉल्व हो जाएगी, आपकी मैट्रिसेस से सॉल्व हो जाएगी. Why are you using a complicated tool for that? So you should be able to see which problem is actually can be solved using the simplest method. Simplest way से जाना चाहिए. So this is basically the optimal design formulation process. That first you see why do you want to optimize something. Choose design variables. Now, as an engineer, somebody can come to you that, okay, design, give me an optimized solution to this problem. Then you should have enough information, you should have enough knowledge that you extract the information which you need for making the problem. Now, the layman आएगा उसको नहीं पता optimization क्या होती है, constraints क्या होती हैं. You have to come out. He will talk in. जैसे मैंने कहा था कि मशीन पे पहली जो जॉब है उसको 1 घंटा लगता है, तो 2 घंटे लगते हैं. फिर आप पूछोगे कि आपकी कंस्ट्रेंट तो नहीं है, वो कहेगा हाँ मैं तो 12 घंटे से ज्यादा इसको नहीं चला सकता, चलाना नहीं चाहता, उसके बाद मुझे ओवर टाइम पड़ता है ना. Then that means we should be able to convert a physical problem into a mathematical problem. Formulate constraint, objective function, variable bounds, and obtain a solution. This is the total process. This is the total process for formulating a design problem and getting the solution. So this is same, we are repeating again. This is in mathematical term, that optimize 250 plus x plus 75 y, that is the objective function, subject to these constraints. Design variable we have discussed already. Design constraints also we have discussed. Objective function we have discussed. Variable bounds we have discussed. Now these are some of the areas where we have collected where optimization, particular type of optimization techniques can be applied. This I'll give you, no problem. So linear programming, inventory management, traveling salesman problem, blending problem, that means you are mixing something. The only requirement is that the objective function as well as the constraints will have all the degree of single degree of one. Okay, none will be non-linear. integer programming, geometric programming, dynamic programming, such methods, some you should go through it. How to make the time taken to solve a problem minimum. You have a very big area, wide area. Let's say x can vary from -10 to +20. How to come to a solution quickly? कंप्यूटर वाले पढ़ाते हैं कुछ हमें सर्च मेथड्स, है ना। बहुत है कि आप शुरू करो एक देन टेक एन ए पॉइंट वेयर द वैल्यू ऑफ द फंक्शन चेंजेस, फिर उन दोनों के बीच में, दो पॉइंट्स के बीच में करना शुरू करो. वी विल नॉट गो इनटू दैट, यू कैन रीड इट. गेसिंग मेथड्स नहीं है, दीज आर साइंटिफिक मेथड्स. दीज आर न्यूटन रेफसन तो है, बट इसमें इंटरवल हार्विंग मेथड, स्ट्रेट लाइन मेथड, बाइसेक्शन मेथड, these are the normal methods which are being used. Binary method. So we have many methods which are available. We will not go into it because I am not going into the mathematics of the things. These are the other things which have been introduced into, widely used into optimization. ANN, artificial neural networks, genetic algorithms, somebody will discuss this, and colony optimization, I have told you. Fuzzy logic. What is fuzzy logic? Fuzzy logic is, people say no logic. When you have fuzziness, it may or may not rain, right? On the other side, we have a binary system. It will rain or it will not rain. It may or may not rain. The student may or may not pass. There are some chances. That means there is no concrete thing that which can say that okay, the students will pass or it will rain. So fuzzy logic also has been used. Or now fuzzy logic कहने का fuzzy है, but it has been mathematically solved. फजी लॉजिक को लगा के बहुत सारी प्रॉब्लम सॉल्व हो गई हैं. सिमुलेटेड एनीलिंग इज बेस्ड ऑन हीट ट्रीटमेंट प्रोसेस, कि आप हीट करो उसके बाद स्लोली उसको कूल करो, है ना. एनीलिंग तो यही होती है, यू हीट इट टू अ हायर टेम्परेचर देन स्लोली कूल इट. सो इन बिटवीन इफ यू फाइंड समथिंग यू टेक इट. पार्टिकल स्वार्म ऑप्टिमाइजेशन ये भी डिस्कस करेंगे. पार्टिकल स्वार्म जैसे इफ यू सी इन द स्काई, द बर्ड्स विल फ्लाई इन एरोडायनेमिक शेप. एरोडायनेमिक शेप कहां से आई है? दैट इज, यू सी वी हैव लर्न्ड फ्रॉम बर्ड्स. जो एरोप्लेन में बनाया हो उसी शेप में बनाया है, बिकॉज एरोडायनेमिक शेप इज बेसिकली लीस्ट रेजिस्टेंस शेप, जिसको एयर की रेजिस्टेंस कम से कम है. एंट कॉलोनी ऑप्टिमाइजेशन क्या है? एंट्स का छत्ता है मधुमक्खी का. आप देखोगे कि वो एक ही रास्ते से सारी जाती हैं. दे डोंट फ्लाई इन डिफरेंट डायरेक्शन टू गेट फूड. हनी कलेक्ट करने के लिए जाती हैं. उन्होंने एक बार रास्ता ऑप्टिमाइज कर लिया तो उसी से ट्रैवल करेंगे, शॉर्टेस्ट पाथ. दैट विल बी डिस्कस्ड इन द लास्ट डे. These are some of the references. So this is a basic introduction to optimization. Real optimization lectures will be will be starting after the lunch at 2 o'clock. Please. Any questions you have?